Hi everyone, this is Sugantha Priya, Assistant Professor, Department of Computer Science, Dr.S.N.S. Rajalakshmi College of Arts and Science. This presentation is about operating system structure. Operating system structure. A structure of an operating system determines how it has been designed and how it functions. We want a clear structure to let us apply an operating system to a particular needs. Because operating systems have complex structures, it is easy to create an operating system in pieces. Much we break down into larger issues into smaller and more manageable subproblems. Simple structure. It is the most straightforward operating system structure, but it lacks definition and it's appropriate for usage within tiny and restricted systems. There are four layers that make up the MS-DOS operating system, that is application programs, resident system programs, MS-DOS device drives, and ROM and BIOS device drives. So operating systems such as MS-DOS and original Unix did not have well-defined structures. There was no CPU execution mode, user and the kernel. So errors in this application could cause the whole system to crash. Next is a monolithic system. The monolithic operating system controls all the aspects of the operating system operation, including file management, memory management, device management, and operational operations. The core of the operating system of the computer is called as a kernel OS, and all other system components are provided with the fundamental services by the kernel. The monolithic operating system is often referred as the monolithic kernel. Multiprogramming techniques such as batch processing and time sharing increase the processor usability. The main procedure, service procedure, followed by the utility procedures. In this organization structures, the entire operating system runs as a single program in the kernel mode. In the system, any procedure can call any other procedure. The basic structure is the main procedure that invoke the requested service procedures, a set of service procedures that carry out the system calls, a set of utility procedures that help out the system procedures. Next is the layered system structures. As the name suggests, this works in layers starting from layer 0 to layer 5. The layer 0 is the process allocation and multiprogramming. Layer 1 is a memory and RAM management. Layer 2 is the operator process communication. Layer 3 is the input output management. Layer 4 is the user programs, and layer 5 is the operator. The OS is separated into layers or levels in this kind of arrangement. The functionalities of each layer is separated in this method, and the abstraction also is an option. Layer 0 is the process allocation and multiprogramming. This layer deals with allocation of processor, switching between the processes when the interrupt occurs or when the time expires. Layer 1 is a memory and RAM management. This layer deals with allocating memory to the processes in the main memory. This RAM is used to hold the parts of the process. Layer 2 is the operator process communication. In this layer, each process communicates with the operator user through the console. Layer 3 is the input-output management. This layer handles and manages all the I/O devices. Layer 4 is a user program. The programs used by the user are operated in this layer. Layer 5 is the operator. The system operator process is located in the outermost layer. Next is a client-server model. A client is basically a consumer of service, and the server is a provider of services. A client requests some service from the server, and the server provides the required services to the client. The client and the server are usually software components running on independent machine. This is an example of the client server model. The client and the server are connected together with the request and service. Next is processes. What is a process means? A process means it is a program in execution. A program is a basic unit of execution in an operating system. Different process may run different instances of the same program. At the minimum, process execution requires the following resources: memory to contain the program and the code and the data, a set of CPU registers to support the execution. Next is the process creation. A process may be created in the system for different operations. Some of the user events that led to the process creation are user request for process creation, system utilization, system initialization, batch job initialization. The execution of the process creation system calls by running a process. The creating process is called as a parent process and the created process is called as a child process. A child process can have only one parent, but a parent process can have n number of children. Both and the parent and the children process have the same memory image, open files and environmental strings. However, they have distinct address space. Next is the process creation. The process creation is done in different stages, like each process is allotted a PID with a execution, exit and wait. Threads. A thread is a path of execution within a process. A process can also contain multiple threads. For example, in a browser, multiple threads can have different types of threads. MS Word uses multiple threads, one thread to format the text, another thread to process the input, etc. A thread is also known as a lightweight process. Next is a thread usage. The thread usage, we have a web server process that is interconnected with the kernel in the form of network connection. So we have a dispatcher thread, worker thread and the web page cache. So we have two different types of spaces like user space and the kernel space. Thank you.